We'll proceed in vector and commercial calculus. Vector and commercial calculus. This is the topic that we are pursuing for some time. Vector and energy calculus. Vector and commercial calculus. So, commercialization or the energy calculation happens when we have magnitude and direction, both. Okay, that is required. Magnitude and direction. If I know magnitude and if I know direction, then I can estimate everything. If I know the direction, if I do know the direction in which something is moving, and if I know the magnitude, the power of it, like a motorbike or a horse is running, then there are only two questions here. Horse is running at what speed? People they generally they know the weight of the horse because weight, mass, and velocity together they talk about momentum or something like that. But anyway, what is the velocity of the horse? Horse weight people know 400 kg or 500 kg, something like that. In what direction it is moving? If someone knows this much, then he feel complete. After that, he can calculate many things. But if he knows the speed of the horse, then it is incomplete. He does not know in which direction it is going. If he knows the direction in which horse is going, then speed is required. Both are required. So magnitude and direction. If someone knows magnitude and direction, then he comes in a phase to calculate many kind of matrix. He can fill many matrices. If there is a matrices and then it needs lot of data, if you know the magnitude and magnitude and direction, then you can fill in lot of data. So energy calculation through vector and then manipulation, energy representation through vector and manipulation through calculus, energy representation through algebra, energy representation through vector. People typically think about a linear vector. Energy representation through algebraic vector. Now it makes sense. And then energy calculation through calculus. Okay, so there are how many things we are bringing in here? Vector we are bringing in, algebra we are bringing in, vector we are bringing in, algebra we are bringing in, and calculus we are bringing in. Algebra is common between vector and calculus. Okay, algebra makes anything variable. That is the greatness of algebra. Numeric is good, but it is only constant. If you see the programming, C programming, Pascal programming, C++ programming, I don't think it is there in kind of Python. Okay, Python, the literals, typically literal are considered as constant or integer numbers, integer float, complex number, or a string. They are considered as constant. Constant in the sense that their memory region, whatever is there, it will not change. If you want to change a string value, then it will point to new memory region. But whatever is there, it will not change. So constants are there everywhere. So if it is constant, then it is considered as numeric. If it is numeric, then it is considered as constant. If you need variable, like if you see the Python, then there are mutable and unmutable. So unmutable are generally called constant, and mutable, which can be changed, means their memory region can be overwritten. Means if I know a list, if I know a tuple, if I have a tuple data in Python, then tuple data, the data when I have to initialize the tuple at the beginning only, and wherever it goes, the data will never be changed. If you lose the reference of the tuple, then data will be cleaned, but data will not change. If you want new data in the tuple, that is not possible at all. New data in the tuple, it is not possible. New data in the integer, it is not possible. Integer location will change. If someone tries for the tuple, probably that is not guaranteed, but its location will change or something like that. If you have mutable like list, dictionary, this kind of thing, then you initialize the memory region and that memory region will keep changing. Okay, in dictionary, key will not change. Key is a kind of unmutable, non-mutable. So fixed and variable, they always happen. It's there. So numeric side in mathematics are fixed. They will not change. Whereas the variable part is considered through algebra. So non-mutable, unmutable in the Python is numeric and mutable in Python what we see is algebra. Algebra we say x plus y, but later we will feel what is x and y. X and y would keep changing. Okay, that is algebra. A variable representation of fixed thing. Fixed is highly important. You cannot go with variable here and there or something like that. You need fixed thing. Anyway, now if you have algebra, then manipulation of algebra when you have independent and dependent component. Algebra can also be in two terms. One is independent component and other is dependent component. So that is if that kind of scenario we see in algebra, okay, if that kind of scenario we see in algebra where some variable are independent and some variable are dependent. Okay, in that sense, it comes into arena of calculus. Vector manipulation, vector manipulation through calculus, vector manipulation through calculus comes into the picture. I'm sorry, algebra manipulation that comes into picture through calculus when kind of algebra is in two arena, independent and dependent. If it is independent and dependent, then the calculus comes into the picture as when the manipulation of the algebraic variable is required. If there is no concept of independent and dependent, only variables are there, then simple calculation can happen like x into x is x square. But if one x is dependent upon other x, then it is x square by 2. Okay, x into x is x square. This is algebra. But one x is independent and other x is dependent upon this x, then x into x is x square by 2. X square into x. One x is independent and other x square is dependent upon this. X square into x is x to the power 3 by 3. This is integral calculus. This is how algebra is manipulated when there is dependency and independence. If there is no concept of dependency and independency, x square into x is x to the power 3. By 3 is not required. There we land up into calculus. That is little bit different. Now if I have a static vector 2I plus j, then this static vector is alright. I have a vector 2I plus j. This is x axis, this is y axis. 2I plus j. This is a static vector. But instead of that, now I have 2xi plus yj. 2xi plus yj, 2xi plus xj, minus yi plus xj, xi plus yj. This kind of term comes, then vector also becomes variable. Means every moment, if this is x-axis, this is y-axis. If I have equation like minus yi plus xj, this is typical example. If this is x-axis, then y is 0. Everywhere it is xj, x and direction is j. If I say y-axis, then it is minus yi, x is 0. Then minus yi, in this minus x direction y here it is 0. Then if you go, the power will grow. So everywhere here on x-axis, the vector was along this direction, vertical direction. On y-axis, vector is along horizontal direction. Same vector is changing its shape depending upon x and y variables. So many things are there. Now, what about calculus? Calculus computation over algebraic vector, or called vector field also. Calculus never operates on vector. Calculus operates only on algebra. So component by component, someone can do calculus upon it, or someone can calculate the magnitude If it is minus yi plus xj, then its magnitude will be y square plus x square square root. Now it is full-fledged algebra where there is no direction. In that sense, calculus can be applied. But on minus yi plus xj, calculus cannot be applied. Calculus is a game of algebra. Okay, vector is a game of static vector and algebraic vector, wherever it suits. Anyway, we are in a situation of calculating flux. Okay, so this is the new topic that we have started in energy calculus. Okay, that is flux, calculation of flux. Flux means if I have a velocity vector and velocity is passing through a area, then how much is the throughput? Okay, makes sense. So how much is the throughput? Like if I'm giving example of horses, there are horses running. Okay, so many horses are running in behind one by one together. Okay, one horse, one horse, one horse, one horse, one horse. All horses are running behind one another. Now there is a circle like this. There is a circular area. Now there is a no terminology of curvature we are talking. So there is a circle like this, and horses are in the queue. Okay, so this is a stream of horses. Stream of horses. Like this consists 100 horses. One horse, two horse, three horse, four horse, five horse. Like this, horses are in queue, and they are crossing this area. Okay, then how many horses are crossing per second? Or okay, if this is little confusing, then I always give example of fluid. So lot of fluid is passing through. Lot of fluid is passing through. Now I'm curious to know that what is the volume of the, how much is like river is passing through. There is a river that is flowing. Okay, can someone tell me how much meter cube per second is the water that is passing through? If I stop the river, if I stop the river, I stop the river, and then can I see that whatever? If there is a river, then can I estimate how much cubic meter of water per second it is flowing? Okay, in another fashion is that if I put a tank, a very big tank of kind of 1 million meter cube, 10 lakhs meter cube, that is a big tank. Now I make some arrangement that full water of the river will go in the tank rather than flowing through. Then how many seconds it will take to fill it through? That much is the meter cube. If 1 lakh, 10 lakh, 1 million, 1 million, it fills in 60 seconds only. In 60 second river, if you take river like Amazon or Ganga, okay, I don't think Nile river throughput is very high, but river like Amazon or Ganga, their throughput is very high. Means they are very wide and water content is very high. So in that sense, it may take not even 60 seconds also to fill 10 lakhs meter cube or something like that. But if it takes 10 lakhs, then how much is the throughput of the river? Then it is 1 million meter cube by 60 seconds or whatever comes. That much meter cube per second is the flow. That much meter cube per second is the flow. How I can calculate it? Okay, to calculate it now, the one way is that now take a kind of a or make an arrangement that full water would flow through a pipe. Make sense? Full water, full water of the river should flow through a pipe. This is river. If this is river, then full water would flow through a pipe. Okay, and it would flow in a way that there would be no water, there would not be any water congestion here. Water logging should not happen here. If water logging is happening, then full water is not flowing. Full water should flow through a particular hole. Okay, if that is the case, full water is flowing through the particular hole, then if you know the velocity of the water, take a big, little long pipe, and then through the pipe, calculate the velocity of the water, velocity of the liquid, and then calculate the area of this hole. Velocity of the water in a pipe can be calculated easily. So if there is a pipe through which full river is flowing for some duration, some segment, then river is taking its normal course. And then there is no water lodging on the source side, so that full water is flowing. Now in that sense, if someone calculates the velocity of the liquid and then multiply by the cross-sectional area, then that is the volume that is flowing through the river. This is called flux, flux of the river. What is the flux of the river? Flux of the river is 10, means 10 meter cube per second water is flowing. Flux. Line integral, if you remember, then we talked about energy calculation. Force into displacement is net energy, that is joule. Here, velocity into surface area is flux per meter cube by per second. Per second, how many meter cube of water is flowing? So that is called flux. Flux, throughput, volume per second, whatever it is. So now the war is going on. Now we are contesting a war to calculate the flux. What is war? Velocity you know, right? Area you know, right? Then multiply it. That is the flux. What is war and this kind of situation you are talking about? So simple. It was simple there also. If I have a force, if I have a force and it is displacing one item, force displacing one item x distance and force is y, then net energy is y into x. Why you need calculus? So if force is 10 and displacement is 20, then 200 joule is the energy. Simple, right? Then why you need calculus? Calculus is required when force is algebra. Up, and force has a direction. Algebraic vector. If force is a simple vector, then again you don't need calculus. Certainly. So if there is a displacement that will happen along x-axis, like I have a big weight that is kept on the ground. If you make force like this, weight will not go up. It will stand there only. Or make an arrangement that that weight will move only along x-axis. Okay, like rail will move only along x-axis, or a car will move only along x-axis. A human cannot lift the full car, not possible. Car is highly weighted, but a human can push the car. That is possible. Now, if this is a car, if this is a car, if this is a car, and human is pushing along the car, then full energy of human is going along the car. Force into displacement is the energy that human body imparted on the car. But if human is pushing like this, perpendicular, car cannot be lifted and car cannot be moved. So net result is human is not imparting any energy on the car. Human will not feel exhausted also. Little bit he will try. If he does not see moving, then he will push off. Okay. So force vector dot displacement vector is the energy consumption from the energy source. So if force is at theta angle from the displacement, then force magnitude into how much displacement it moved into cos theta. That much is the energy that force imparted. Okay, this force is applied like this at an angle, and then it will move only horizontally only. This is the way it is made. How much it moved and how much is the force, you multiply into cos theta. This is the angle it made theta, cos theta. If theta is 90 degree, cos 90 is 0. If it is moving 90 degree, then cos 90 is 0. Cos 90 is 0. Means nothing moved out. Similarly, okay, I'll go beyond that. Now, force is, now I can say, what is your force? My force is I plus j. This is x axis and this is y axis. What is force? Force is I plus j in this direction. What is your displacement? That is I. Now, I plus j dot I, that is the work done. So I plus j is the force vector whose magnitude is square root of 2 and displacement is along I vector. How much, how much, how much if it moves 1 unit and this is the force vector I plus j, then net energy that is imparted by the energy source is I plus j dot I 1, or force magnitude that is square root of 2, displacement is 1, and cos theta I plus j means 45 degree it is making with the x axis. Cos theta means cos 45 degree, 1 by square root of 2. If that is the case, then it is square root of 2 into 1 by square root of 2, 1. Simple. Okay, now force is minus yi plus xj. Here is the problem. If force is not a static vector, it is an algebraic vector which keep on changing. If this is x-axis, this is y-axis. If I go along x-axis, force is like this: yi minus xj. That is the force. Force is along y direction, and if I go along x-axis, it is xj. If I go along y-axis, then force is minus x-axis direction, and this is like this, and force will grow if I go up. Here it is like this, here it is like this. If I take 1 comma 1, then here it will be like, it will make a round. Force is making a round. Everywhere force vector is different depending upon x and y. Now you calculate if any item is moving along x axis 1 unit because of the force minus yi plus xj, because direction of the movement is along I only. Make sense? Now the direction of movement is along I plus j. Direction of movement is along xi plus yj. Now the force vector is algebraic and displacement is algebraic, or displacement is happening along a ellipse. Hop, hop, hop. Like I should bring a bolt. I always give example of a bolt. Okay, so consider there is a bolt or there is a lock. Hop, hop, hop. There is certainly a lock. I don't know it will go inside or not. Okay, it will not go. So I'll bring another one. I believe it would go. Okay, there is a lock. There is a lock. If I lock it, then it will go. Okay. There is a lock. And lock I'm putting inside this. Now if I make it move, it will move only in this direction. Okay, it may fall. So I believe if I lock it, then it will not go inside. That is the fear. Okay, it will not go inside. Anyway, I can place it inside. Now this is the lock that will, if I move it, it will move only along this path. It will not go up and down. Okay, so that is the concept. So if there is a lock like this, if there is a lock like this that will move, or there is a bolt that will move around, so the direction of movement is a circle. If direction of movement is a circle, it is not a straight line. If it is not a straight line, then if I was saying car would move along x-axis, that was a straight line, I vector. But here, the vector, if I talk about the vector equation of the circle, vector equation of the circle cannot be a static vector because that is a straight line. If there is a, if I say static vector, then here vector would be like this, 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 here vector. So vector is variable if I move in x and y. So displacement is algebraic vector. Force is algebraic vector. Force is also moving like this. Or force is xi plus yj. Then if it is centered at the origin, then force is radial xi plus yj. Whereas displacement is like this. Okay, both are variable. both are bunch of vectors. This is what we can say. In that sense, under the force xi plus yj, if item is moving in a circle, then from point one location on this curve to another location of the curve, if item is moving under a force field, how much energy the energy source is losing, which is energy source is losing, for which this force field is represented through. So that is comes as a complex idea. Okay, similarly, if I have a velocity, if I have a liquid that is flowing through an area, and liquid is not straight, liquid is algebraic vector. The liquid that is flowing, somewhere it is like this, 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 and the area through it is flowing. The area is also algebraic. How area can be algebraic? I can't believe so. If I have a, see, this is a cross section and area is flat. Area cannot be algebraic. I consider that force field is, the velocity field is algebraic. If item is moving, item may move like this. If item is moving straight, then velocity is a numerical, it is a constant vector. But if item can move like this, possible, like a bee, B. B is moving like this. It is possible. But when it is passing an area, if I have a curve like this, it forms an area. Area is flat. What is area vector? Velocity vector I can understand. The way velocity is going, that is the velocity vector. Everywhere it is different. So it is algebraic vector. But what about the area? Area vector is perpendicular to the area. If this is the area, this is x-axis, this is y-axis, this is z-axis. If that is the case, it is kept on xy plane. If it is kept on xy plane, then area vector is perpendicular to the surface. It is in z direction. Area vector is in y direction. This is yz plane. Area vector is in x direction. This is yz plane. This is xz plane. Area vector is in y direction. Straightforward, right? No. Consider that I always give this example. Okay, consider that I, okay, if this is the curve, I sew a cloth on the curve. Okay, a cloth I am sewing on the curve everywhere. I sew cloth on the earth, on the curve. If I am sewing cloth on the earth, no, I pull this cloth. Okay, same thing, right? The area was represented through this curve. Now this area, this cloth, I am just pulling it. Now water is, now this is the surface, this is the surface. Water is flowing through the surface. Now if you see this surface is not flat, it is uneven. Here, if I talk about area vector, earlier the surface was like this, a surface is like this. Now, earlier the surface vector was perpendicular to this in this direction. Okay, now if I move this, the surface vector earlier is in this direction. Now surface vector here, it is perpendicular to the momentary surface here. What is the momentary surface here? Momentary surface is like this, the surface vector is like this, this. Here it is like this, 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 this. So surface vector may not be static vector. It is again algebraic vector. If velocity vector and surface vector both are algebraic, then we cannot calculate the net flux just by multiplying it or doing the dot product. Okay, we can do dot product only when they are in same direction. They are in one direction. If velocity vector is like this and area vector is like this is in yz plane. If that is the case, then area vector is along x-axis and velocity vector is along this. Velocity vector dot product with the area vector is the net flux it is passing through. If velocity vector is like this and then area vector is like this, velocity vector is in z direction and area vector is in x direction, then k direction velocity vector. Then the net flux come out is whatever the velocity is, vector is dot product with the area vector, k dot I 0. no liquid is flowing through this surface because all liquid is going like this. If little bit, if I tilt it, then velocity vector is like this and area vector is like this. Then this angle is not 90 degrees. In that sense, some liquid will come out from here. Velocity vector dot area vector is the net flux. But if velocity vector is algebraic, keep on changing, and area vector is algebraic, keep on changing at different places, then in that sense, we have to use, after all, dot product is multiplication only, right? Velocity vector magnitude, area vector magnitude cos theta. That is the net flux. Okay, after all, it is multiplication only. But when we go in algebra, then it is not simple multiplication. Then we will come into a term of independent and dependent component. And there we will bring in integral calculus. So velocity vector dot area vector is the net flux. Force vector dot displacement vector is the net line integral or net energy. Okay, but if we talk about calculus, then force vector dot d of position vector is the net net energy. If it comes in calculus, then then the displacement vector, force vector dot displacement vector will be replaced as d integral d of position vector. Similarly, here velocity vector dot area vector is the net flux. Area vector will be replaced by d of p, again position vector. Okay, but this position vector will represent area, and there in energy calculation, position vector was representing a curve. Okay, if this is the displacement along a circle that we are seeing, if I take any point x comma y, if I take any point x comma y, then from center, if I draw a vector from center, if I draw a vector, then this is position vector. From center, if I draw a line to this point at position vector, this is displacement vector along the displacement. But if I take any point P and from center, if I draw a line, that line is position vector. Force vector dot d of position vector is the net energy. Similarly, if there is a surface like this, okay, if there is a surface like this, now the story of curve is gone. If there is a surface like this, consider this is centered at the origin. Now from the inside the origin, I take any point P here. This is position vector at the surface. Any point P here. Earlier, if I took the curve, it was x comma y. So the position vector was xi plus yj. Now if I take any point here and from the center of it, if I draw a line, then that position vector is xi plus yj plus zk. Now velocity vector dot of d of position vector. That is the, now it will give you the net flux as per the calculus. So velocity, this explanation is not available in any of the book. You go and try. Okay, this much no one would describe. So force velocity vector dot d of position vector. That is, position vector will come now as an area 3D d of xi plus yj plus zk. This is the net calculation of flux when the velocity is algebraic vector and surface is algebra. Surface is algebra now. Surface is not flat. If it is flat, then the surface area vector is a straight line. Then it is a constant vector. But here, the surface area vector is like this. Here it is like this. Perpendicular I am taking. It is everywhere surface area vector is different. In that sense, if I am trying to find, consider there is an energy source that is kept at the origin. There is an energy source that is kept at the origin, and its equation is Q, or electric charge. There is electric charge that is kept at the origin. If it is kept at the origin, the net kind of electric field is Q, that is the charge, R vector divided by R to the power 3. R is radial all the way. In that sense, how much is the flux of this? Flux means in this, on this, if there is a charge, electric charge that is kept at the center of this, and from this electric charge, full electric wave are flowing. How much is the wave that is flowing through the surface? That is flux of the surface. Now, in that sense, electric charge is algebraic vector q into r vector divided by r to the power 3 if I talk in a spherical coordinate system. Otherwise, q into xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. Now, if I talk about the surface vector, then I can take any point x comma y comma z, and from center if I draw a line, that is a position vector of the surface, that is xi plus yj plus zk. Then it will become a kind of the velocity vector or the charge vector, that is q xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. Dot product d of position vector xi plus yj plus zk. What is problem here? If it was force into dot of the position vector, then force was F1i plus F2j if it is 2D. If it is 2D. Dot d of position vector of the curve, then it is xi plus yj. Y is dependent upon x. Then whole we can place in x only. If it is a circle, then y equal to square root of a square minus x square. Xi plus square root of a square minus x square. J. That is position vector. Actually, everything comes in x only. We can deal with dx only. But here in 3D, z is dependent upon x and y are independent to each other. If I have position vector xi plus yj plus zk, then z can be written as fxy, function over xy. This this reduced as q into xi plus yj plus zk. Z is function of x and y. K divided by x square plus y square fxy whole square to the power 3 by 2 dot d of xi plus yj plus fxyk. Now you calculate the surface area. This is kind of a abstract way we started calculating the surface area vector and then doing calculating the net flux. Amazing, mind blowing. So this representation is not available in any of the book. Whatever we are going to talk now, after this, it is not available in any of the book. You can check it. Anyway, don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. So we are looking to proceed on this great fundamental. This is not only kind of doing the flux calculation. Slowly we will move into multivariable this kind of scenario, calculating the surface integral, volume integral, and bigger than that. That is highly useful in artificial intelligence kind of mathematical computation.